Hello everybody, I want to introduce you to the e-bike. It's just an electric motor connected to a bike and a chain system. The main reason we built this is because we go to a campus that's quite large. For example, me, I live in the Wheelie, which is a good 5 miles away. So if you don't want to pay for gas, it's a good substitute. One of the main reasons is just because, trying to get from point A to point B is the main reason we built this, but also with the new law coming out that scooters have to be registered, and so you have to pay taxes, have a license, all these different aspects. This is a solution where you get around those if you save you a little bit of money with a college student, so this is our bike.
Okay, so these are our initial design concept sketches. Our first design was a direct drive motor. As you can see here, the advantage of direct drive system is we have no tensioners and we have no chains. So the motor is attached to the hub of the rear wheel, and that's our drive system. A disadvantage of this system is you have to have a specialized motor and hub assembly to allow for the bike to propel forward. Our second concept is the battery and the motor being on the same platform, and the motor being connected to a chain to the drive system, the gears of the bike. The disadvantage of this system here is it's the least powerful of all three of our concept sketches, and the weight becomes an issue. But the advantage of this system is we have a wide variety of motors that we can use, and it's cheaper. Our last design sketch is a pneumatic air controlled system. This compressed air system is the most complex of all of our three designs. The advantage of this system is it delivers the most torque and power to the wheels. The disadvantage is the weight, and it's very expensive. As you can see from our bike, we went with the second concept sketch. We went with a slight variation. We had the motor here, and instead of having the drive system connected to the pedals of the bike, we connected the drive system to the rear wheels of the bike. We also had to include a tensioner for more support.
So for our initial design, our base was made off of an aluminum alloy that would provide enough strength to hold our system. We mounted that base to the seat and to this other bar that would go down from our hub. We also bored out this bottom sprocket taken from another bike and included two bolts to protect against the shearing force that this would encounter as this motor powered this system. After running some initial tests, we found that not having a tensioner really hurt us, because this chain would jump off into the wheel and it brought our entire system down, so it bent all the metal. So an advancement that we made was we chose a different material, which is like a really thin steel, as well as include a tensioner to keep this entire system in tension, because as this motor is going to turn, this chain will become slack and become compressed. So this tensioner will keep all the system straight and allow the system to run smoothly. Another advancement we also made was we included both batteries on the second system. As you included both batteries, the shearing force became too large and it overcame and actually sheared these bolts. So what we did was we included more bolts into the hub of this tire into the sprocket, and we ran that, and it actually works really well other than the weight distribution. So some few further advancements that we made would maybe like a redistribution of weight, as well as some different kinds of materials that would hold up the system, and definitely the tensioner, because the tensioner right now works really great for our application, but might not be great for mass production.
Alright, this is our battery operated system here. As you can see, this is our battery. It sends power through the relay all the way up to the push button. Accessing the push button will allow us to access the motor, give the motor power. The motor drives this sprocket here, which turns our drive sprocket here and propels us forward. And he's off.